Okay, let us start. Good morning, friends. Let's continue on the processes we have been discussing. Is the slide visible?
Yes, sir.
Okay. So, under development, we have discussed a number of very important processes, process for debugging, bug tracking, and varied types of testing. The last process in this that we will briefly touch upon is the documentation process, which often turns out to be quite neglected area and causes severe long-term damages because without proper documentation over period of time it gets more and more difficult to maintain and manage the software. And particularly even if the documentation gets done at the beginning of a project, as the life cycle goes, as more and more changes are made to it, very often the documentation is not properly updated. So that's a concern area, and there has been some automation attempts to address that. But before that, let us understand that there are primarily two types of documentation. One is product documentation, that is product that is being developed, and so you document on that, and you document how to perform various tasks with it, how to use it, so to say. So this will be subclassified into system documentation, which describes the product itself and its parts. It includes requirements documents, like some of these you have done as a part of your assignment in theory as well as in the lab. So it could be requirements document, design documents, architecture descriptions, program source code with documentation, test plan, FAQ, and so on, frequently asked questions, and so on. The other is user documentation, which you have not done, but you are very often using. You are using certain library, for example, you are using C++ standard library. You go to the library site and find out how to use a vector, how to insert an element into a vector, how to remove an element from a vector, and so on. So the documentation provided there is telling you how to use that. Now, user documentation could vary widely depending on the type of the system. For example, when it is a library product, then user documentation primarily is documentation of APIs and classes. When it is a GUI product, then user documentation would mean different screens, then navigation, workflow, and so on. Earlier tutorials, user guides of different kind, and so on. And naturally, earlier, most of the documentation used to be textual with images at times, but now you have a very strong range of documentation, which are also in terms of small videos. Like in YouTube, you always go and find out how to use something. So this is the product documentation, and the other are process documentation. That is what kind of processes that have been followed. And one second. One second. So that includes different project plans, test schedules, reports, different meeting minutes, and so on. Even there could be client correspondences and so on. So obviously, process-related documentation would come to you when you kind of somewhat grow up in the organization. So currently, I will discuss this towards, at the concluding part also, that what we are primarily focusing on is kind of software engineering for an early developer. Say, your first maybe 2 to 3 years in the organization. there's a whole lot of software engineering issues which you have to take care of as you grow up in the organization, as you become from a developer, you become a senior developer, you become a project lead, you become managers, and so on. So I will just in one lecture I will talk about those issues, but we will not get into those for two reasons. One is certainly we are running out of time, and the other more important reason is these processes are not easy to understand as an outsider. You need to have a couple of years experience in the organization to be able to appreciate them. Okay, coming back to documentation. So process documentation, I mean, just to know that they exist and they will have to be done, but your focus should be in terms of doing system documentation and user documentation. Of that, different requirements, design, modeling documents you have dealt with. One very major area and often neglected area is documentation of source code. It is quite painful to document the source code. So it often gets neglected, and the more important thing is it does not get updated. So there are a number of tools as well which help you partly automate this process. So there's a tool called Doxygen. Doxygen often it is referred to as. So in that, you can put your very specific information as comments. For example, before a function, you could say what does your every parameter mean with certain annotation, like you say at this at number means this. So what happens is when you take this kind of a source code and run it through the Doxygen kind of tool, then it will extract those tags that you have put in the comments and will generate a nice user documentation from there. So these are nice things which you should learn and learn how to automate. Okay, so leaving it here, let us get to the two primary maintenance processes. Of course, I mean, they are relevant as well for development, as I have already mentioned. So maintenance also needs to do debugging, lot of issue tracking, testing, and so on. But two core areas of maintenance, which are also partly for development, are release and version control. So you know that software is a very live entity. It's not like making a building. We discussed at the very beginning that's where the additional challenge lies, that it does not ever get frozen in terms of its built or in terms of its requirements. So a good software, well-built software, will usually go through multiple releases, and we all are familiar with that. I mean, what Windows are you using? We are using Windows 8, we are using Windows 7, we are using Windows 10, and so on and so forth. So these are basically different release numbers. Now, all releases that the software has to go through are not of the same type. There is a kind of a categorization based on its importance, its impact, its severity, and so on. So what you have primarily is a major release. So like you are talking about Windows 10, this 10 is a major release. So a major release will have new features, new architecture, product components, and kind of for this release, you make a full standalone product build. So major releases, I mean, we'll talk about release numbering as well. Major releases will have such numbers. Then you have minor release. Minor release, I mean, you have done a release and there are some requirements of feature changes. Internet Explorer 5 is a major release. But what most of us have used is Internet Explorer 5.5. This 5.5 is a minor release where maybe some significant new features beyond the previous major or minor release have been added. But it is not so big to call it a new major release. And in fact, there are a lot of other company processes related to licensing, processes related to marketing, processes related to pricing get associated with it. For example, your license agreements could be bound to major release. You could say that, well, you are licensing for software version 17, and all minor and other releases within this 17 you will get free of cost. But when we upgrade to major release 18, you'll have to pay for it. So naturally, there has to be something major in a major release, and relatively minor things may keep on happening. But it's still a full standalone product build. Patch release usually is a bug fix release. So patch release is not planned. It is in response to certain software failure. If there's a failure that has happened because of oversight or because of certain system configurations and so on, then you do a patch release. It's kind of typically done on a minor or could be on a major also. And it may be only a set of files, but not the full standalone product needs a build. It depends on the modularization that you have been able to do. If it is not modularized, if your entire code is flat, then a patch release will need a full system build. But if it is modularized well, then only the submodule in which your particular bug fix changes are made will have to be released, which have to be built and tested and with the others and so on. So it is typically released on an ad hoc basis because it's not planned. And often there is a customer pressure to release that. So it has to be released as soon as it can be made available. And often, even though maybe a patch release may have been done for a bug reported by one customer, it is usually customary that you recommend all customers about that patch release to prevent a critical failure. And these are things that keeps on. I mean, we very regularly, our mobile phone or our Android or our Windows keep on saying that update available, please update. So these are kind of typically the patch releases. So some problem is reported on the security, so Microsoft does a patch release and gets that installed automatically in your system. So you did not report that security gap, but somebody did, or Microsoft themselves found out and did that patch release, and as soon as possible they release it and make it available. Beyond patch release, often there is some hot bug fix release. Hot bug fix release is typically in response to a specific customer reported software failure. I mean, maybe one customer has reported that this is happening and this is causing a problem. And maybe that customer is using a Solaris operating system version dating back to 2004, right? So it happens only on that. And when you analyze and look through the bug and do the fix plan, you realize that it is not going to happen on other releases. It is very specific to that platform and specific to that customer's configuration, maybe. So it also, like patch release, is released as soon as available, but typically you do not do a generic release. So that is why I mentioned that the release is ad hoc as soon as possible, but it usually goes via tech support only. So it goes to that specific customer, and obviously we'll do this kind of a release only when there is a showstopper. I mean, this comment is not looking good. You will not do a hot bug fix release for that. The customer says that this is doing a wrong logic, or this is crashing on such and such input configuration on this particular platform. You do a hot bug fix release. And typically both the patch release and the hot bug fix release should be merged in the next major or minor version, because those are the planned release. Then there could be other releases as well, like you may release on new platforms. For example, Intel's pin tool for long was available on Windows and Linux. And then one day they made a release on Android platform. Right? So that's a platform release. It's a major release, but it's of a major release of a different kind, because in terms of the software functionality or behavior or architecture or components, you have not changed anything. But you had to make change in the engineering so that it could be made available on a new platform, on a different platform. So there could be other such types of releases as well. Now, to manage the release, and so that when you make a release and when your customer is using that release, there will have to be a communication sync always through the release team, through the tech support team, so that you talk about the same kind of you are talking about the same release at all point of time. So if adhere to a certain release numbering scheme, kind of which says what kind of release is being used and the specific one. Obviously, like your coding guideline, like debugging guideline, there are release guidelines followed by many companies, usually most good companies. And it also has a relation to release, also has a relation to level of support for various releases, right? Like, for example, it could be that you have signed up for a version 17 with a customer, and your level of support agreement, or SLA, as we say, support level agreement, SLA, it is typically called an SLA. SLA would say, okay, on this you have kind of online support, live support on major releases. If there's a major release done, then you will get it, and you will have a lot of support to help you make that release work. If it is a minor release, then SLA might say that for a minor release, there will be support in terms of the issue tracking system and the mail, but you will not have someone talking to you over video conferencing on telephone and giving that support. For a patch release, you could just say that, well, there will be support only if something breaks. There's no support otherwise, and so on, right? So the release itself is a huge phenomenon in terms of the company, and often it is linked to your customer impression, customer retention, customer loyalty, and particularly with your billing process. I mean, customer will say, okay, these are my requirements I had specified 3 months back. When you make it the next minor release with these requirements, then I will give you this X percentage of money on top of the current license, right? So those are the considerations that you'll have to keep in mind. So let us take a look into the release numbering process. So release numbering process incidentally does not have a standard. I mean, like you have C++ standard, you have testing standards. You do not have a release numbering standard. It is more like a convention in the community, right? So typically, it is 3-part. Numbers separated by dot. The first one says the major release numbers. Then within that you have the minor release number, and then within that you have the patch release number. And more often, the releases would be kind of sequenced in terms of the numbering, though out of sequence things may also happen, because after you have released 4.2.1, there may be a bug reported for a customer who is using 4.1.3, and you may need to release a 4.1.4 after you have released 4.2.1, which means that for many companies and for many products, number of releases might run live at the same time during maintenance, because often it is not easy for, I mean, it's everything is not just Microsoft Windows, where they will just force you to the next release in a way, because I mean, unless if you do not do that, they will stop sending you bug fixes. Many other software will not work, and then when you have been sleeping, having left your machine on, it will sense it that it is idle and automatically do that upgrade. I mean, that's usually is not possible with many customers, because customers have their own business compulsions, preferences as well. So it's not always that customers will move to a later release as and when it is available. It depends on their business situation as well. For example, you have a library release made. You are building a library using which the customer is building other products. So for long, I used to lead a team to build a Verilog front end. We called it Cheetah, Verilog Analyzer. So what it could do is it would do the front end syntax analysis, parsing, and all that, and make an abstract syntax tree model, which can be traversed in multiple different ways, right, with different data structures and so on. So you will, I mean, maybe this is sounding a little sketchy to you, because when you do compilers, you'll understand these processes. So different, other, electronic design automation companies, I cannot name the companies, but the big ones also used to license this Cheetah library. And using that, they used to build different Verilog analysis tools or Verilog-based design tools. Now think about it, if a customer has been using a release from 2 years back and his tool is completely stabilized based on that library, and his customers, the customer's customer, are happy with that tool, then your customer would not be very willing to go to a release done now, which may be improved in several ways. It may be using less memory, it may be faster, but well, the customer will say stability is the most important thing, will not move. So bottom line, multiple releases will need to be maintained by an organization at the same time. So this is a typical numbering scheme, and this often is referred to as semantic versioning. These different numbers also relate to the version of your software. And it's kind of semantic versioning, because though it is just a dot separated number, it tells you a lot about the kind of level in the software that you are in. So 4.2.1 tells me that it is in the major version 4 of the software, so I know what to expect as features. Then it says that it is within that is a minor version 2, so I know what add-ons have happened. And then it says that it is patch release 1, so I know what bugs have got fixed. So though it is just merely a number, referring to the release notes, I can find out exactly what it means. So it has a lot of semantics that come into that. And it goes to that extent that even there have been attempts to have formal grammar define the release numbering schemes. So here are, but again, keep this in mind that this is not a standard. This is just a kind of a common practice, you can say. So for example, let's say this is one scheme, major.minor.build.revision. You can see that these are on within square bracket, which this means that it may be there, may not be there. So after major minor, so it's 1.2, then you say this is build number 12, right? So you are, while doing this minor build, minor release, you must have come across several bugs internally, right? And those meant that you had to build the software again and again and again. And on the 12th attempt, you got it right to be shipped. So you say that this is a build number 12. So this has closer relation to the versioning than just the release number. Your primary release number is major.minor. But these later numbers are more for reference back to the development organization, because the customer says, I'm using 1.2. You say, no, not 1.2, but tell me the full version number. So because it may have gone out in multiple builds. A build may have had revisions, that is patch inside that. So it could be something like 1.2.12.102. Or it could be major minor. Then optionally, when a patch goes out, you put that patch here, it is 3, and then the build number, which is 5249. It's a large number, because builds happen quite often in the system. Okay. So release numbering typically, as I said, is sequential, but in terms of actual release number and actual release may again not be correlated. Of course, a release that is actually made will have a unique release number, but not the reverse. You may have a lot of release numbers which you have actually not released. So Internet Explorer 5, major version 5 had a minor release 5.1. But there was no minor release of 5.2, 5.3, 5.4. They never happened. They directly went to 5.5. So probably while they were working on those minor releases, they felt that those cannot go by themselves. Maybe there are interdependencies, and which was realized during development. And they directly jumped to 5.5. Adobe Photoshop went from 5, major version 5 to major minor version 5.5. And as I said, there is no standard, but often there are alphabetical annotation done with the release number to mean if it is an alpha release. We talked about alpha release. If it is a beta release, which is very critical, or it is a release candidate. A release candidate, it is a notion, is when you say that from development side, you say everything for this release is done. You wash your hands off. I'm done. Now it is totally with the QA team. And the QA team's responsibility is to kind of grind it to the maximum extent they can through the test plan, beyond the test plan, whatever way they want. And only when they are satisfied, then the actual release will happen. So there may be bugs between the point that the development team signs off, saying that this release is ready, to the point that the release team actually agrees that the release can be shipped, right? So during this time, the releases, many companies refer to them as release candidate. So you might want to embed that in terms of your release number. So maybe a release train might look like this: 0.5, 0.6, 0.9. Then you have 1.0. So while we are doing this, possibly you are at a level alpha. You could have said A, or you chose not to. Then you do a beta release. So you do a beta release 1.0, and you say that it is the first beta release. So what does it mean? It means that you are targeting version 1.0, but you have done a beta release, and of the possible beta releases, this is the first one, right? So 1.0B1. Similarly, you could have 1.0B2 with maybe some fixes, some more fixes, B3. And when all those kind of get resolved, all fixes done, then the development signs off, saying that it is now a release candidate. Now the release can actually happen. So you say it is 1.0 RC1, RC standing for release candidate. So with this is expected to be pretty stable. I mean, no known bugs and so on and so forth. But even then, QA team often will find out some issues in that. And then it reports, and the development team has to get back to it, again, go through that processes and create another candidate, say release candidate 2, if more bugs are found and so on. This goes on. And then finally, when some 1.0 RCN gets accepted by the release team for shipment, then you give it a final number, which is 1.0, where you say it is major release 1, which does not have a minor release yet. Right? So this is kind of the practices. I will, we will talk about the versioning. You will understand this even more better then. But you need to keep this in mind, that release numbering and release process, this release train cycle, is very, very critical to manage your customer. So once you have made the release, once you have done the shipment, that gets frozen. That release, you cannot easily withdraw from the market without lot of prior notice and substitution plan, migration plan, and all those and so forth. Right? So let me check if there is any question on the release. It is a very, very critical component of software engineering per se. No questions. Okay, good.
So what if a company refuses to what if your client refuses to update? Like then how is that enforced? Because like we often turn off Windows updates. So
it is finally in life, it is the muscle power. Who has a bigger muscle? Does the company have a bigger muscle or the customer has a bigger muscle? Right. So it has often happened, let's say, talking about Cheetah, it has often happened that it has been 3 years that we have made a major release which some of the customers did not accept. Now, then you sit down with the higher management, maybe at times even with the CEO, and CEO looks at and says that who are these customers? So there are 50 customers of that. 47 have accepted, 3 have not. Now, these 3 are okay. They give you maybe 2% of the revenue of that product. So the CEO says, go ahead. Tell them that, well, the earlier version is not supported anymore. You have to take this new release, will help you in migration. You have a bigger muscle power. Now, on the other hand, out of this 50, again, 47 have accepted. And out of these 3, you have 2 of your key customers who provide for 60% of your revenue. Okay? So they have the muscle power. So then you have to get into dialogue with them, negotiate, and see, why aren't you doing this? Why don't you start a parallel branch with this release, and see that your product gets stabilized and so on and so forth. Right? It depends on all of that. Now it is fine. You can turn off Windows Update, right? If you turn off Windows Update for a while, it's okay. For a longer while, it's okay. If you turn it off for a very long time, it might start happening. And it did happen with, I'm sure, with all of us at some point, is when your other several other software that you use on those Windows are not working properly. Because they have been tested with those fixes that Windows have given. Right. So
nice.
it is a question of choice. Now Microsoft does not give you much choice, because Microsoft does have that muscle power against you and me. But of course, Microsoft also in their enterprise operating system. I'm not talking about the Windows that we use, which is kind of just home or professional version, but the server version of the Windows system, where they have companies like IBM, Oracle, Google using them. Of course, I'm pretty sure they get into a lot of negotiation regarding the adoption of releases, and Microsoft must be maintaining a whole lot of old server Windows, maybe 10 years old and so on, because the biggies do not want to move from that. So that it is an entangled game. I mean, we are talking about business. It is money, and at the end of the day, it is money. You are trying to maximize quality at your given resources to maximize your profit. Your customer is also trying to do that. So it's kind of goes beyond often the developer's level and gets into the actual project management and kind of program management issues as to how you deal with the customer in the right way, so that you can progress with your software, right? And in many cases, like say, for that's why you'll see that in open source software often you do not have that force, because you are choosing what you want. So you'll see in GCC you get a whole lot of old versions available, right? You may choose to download and use that version, but what certainly gets withdrawn is the support on that. So if you are on Python 3.9.3, you will have 3.5.2 also available. You can download, use it, but you will not be able to report a bug on that. If you do, it will not get supported. Right? So that's kind of the dynamics that go on. Does it partly answer your question?
Yes,
Okay.
sir, because I'm more used to the open source thing, not the
Yeah.
company
So
ethics. So I was wondering.
open source, the risk is of users. You are not paying
Yes.
anyone, right? So nobody is. For example, Linux is an open source, but Linux has price.
Sir, you are not audible.
Sorry, typical Delhi schedule. I lost connection. So what I was saying that open source is a different ball game, and it works somewhat like an organization, but it again it's not like that either. But if you look into open source communities, I do not know if you have ever registered with one as a developer. You will see that good
Yeah.
open source communities have a lot of laid out practices, and if you are not following those in terms of the development and the release, over a period of time you'll be thrown out of that group, right? So like
Yeah.
so that, I mean, that's more an organic process, whereas in a company it's completely driven by making money. Otherwise, why did you do the company? You deliver quality, you deliver service to your customer, but you, at the end of the day, you want to make money. So you would like to do everything honestly with your customer, but at the same time maximize your profit. So it does make sense for you to not to have 3 live versions of the project being supported at the same time. You would like to reduce it to 2 or to 1, because then you can cut down on the development team, on the release team, and so on, right? So you have a direct interest in that, and customers have their own interest. If they have to migrate from one version to the other, they will also have costs at their end. So it's a business negotiation at the end of the day. Okay, pretty
Yes.
complex, pretty very interesting. But you will get into that after 5 years if you are in this kind of software companies. Initially, you are developing and you are in the technology. So having said that, the next is to talk about the version control. Now, naturally, as you are doing these releases, you are regularly making changes. You need to manage the version of the software, right? Like you are making a document, you can keep on saying, this is my document 1.0, this is 1.1, 1.2, 1.3, 2.0, and so on. Now, in terms of a software, it's this whole setup of your source files, your header files, source files, supporting files, other libraries that you are using. This is where your third-party library issues are coming up. All those need to be a part of one version, which you have tested works fine. Functionality is working fine. So you need typically a system to manage this. Right? This comes under a broader topic of configuration management, which we will not get time to discuss, but I'm just discussing the version control, which is in terms of the source code. Not only source code, but the source related stuff. For example, you need version control for your test suite as well. Or you have a certain version of the software which has been tested against a particular test suite with test cases and goldens. Now you have upgraded the software, adding some functionality. So some files have got changed, some files have got added, some files have got dropped. Naturally, your test suite has also got upgraded. You have more test cases, some test cases have changed golden and so on. So it is the version of the source along with the corresponding version of the test suite that you'll have to do the testing. So versioning is not only for your program source. It could be for your test cases, it could be for your libraries and so on. So there are several version control tools available. I mean, the most common these days, and all of you who have some interest in open source will know that Git. I mean, we talk about GitHubs and all that. It has, I mean, traditionally probably the most structured version control system has been CVS, which was also free. SVN was created by Microsoft originally for Windows. Later on, it got migrated. So when you do a version, you are basically there is a check-in process. So what you do is, here, as if now this with the cloud, the check-in has become a very usual concept. So what you do is, your current version of files you put into that system, right? And this is where I have put in, and you give it a number, right? You give it a number so that you can check it out later on. That at a later point of time, so you are making regular updates and checking in with different numbers. And you work for 2 days and realize that what you have worked, the changes that you have made are all wrong. So you want to go back to the version that you had 2 days before. So you should be able to give that number and check that out. So that's kind of the whole concept. So the way it does, it uses, let me first go to the diagram, and then I'll come back to this whole lot of text. So it goes like this. So you have what is called a major stream going, where you check in your code. This is what is shown here as a trunk, the green line. Okay. So initially think about yourself only. So you're checking in the code there and regularly checking whether it is working fine and so on. Now, after working for a while, you see that there is a requirement to make some additional features. Now, your version is already stable, so you don't want to jeopardize that. So what you do a branching. Branching is nothing but making an identical copy of it in the system from the point you are branching, and you get an identical copy, but you just give it a different number. Right? So now you could be checking out from 1, so you'll get this, or you are starting from 2, where you are starting to make changes. You make a lot of changes, test that, and compared to the original stuff that you had taken out, you say, well, this is what I call it 3. I just arbitrarily say. And now it is stable enough so that it can become my major development source. So you come back and merge it with the trunk. This is the most difficult, most painful process in terms of version management, in terms of code management, because you have 2 versions of every file. You have some files deleted, you have some files new. So if you have 2 versions of the file, some changes have happened. So you have a view to see what changes have happened. I mean, if you have ever done, say compare file in Windows, in Word, like you have a document and you have made some changes in that document, the original and this document, you can do a compare file to see what all changes have been done. So it's that kind of, and then you say that this change is accepted, this change is not, and so on. So that you create a merged version now on the trunk and call it 4, right? So that process goes on. So you have branched here twice from 4 to 5 and 6. 6 has gone on to development onto 7, and 5 has gone on to development into 8, and then at 10 it was decided that this development is not leading anywhere, or maybe the major customer who was driving this development goes bankrupt, so you don't have a customer for it. So the management says that this development is stopped, so you discontinue. But the other one, which is 6 to 7, that matures into the right kind of requirements, and you merge it back again and call it 9. So this is the basic version management mechanism through branches, and there is, at any point of time, you can tag a branch. So I'm saying that you put a name. Actually, formal thing is you tag a particular name. So every day you are checking out and checking in. Every day you do not want to write on the checked in files that this is something that I will need tomorrow. You don't. So only when you come to a significant point where you might need to refer back to it at a later point of time, after other changes have been checked in, is when you put a tag. So from 1 to 4, changes may have gone in, but you have not tagged. So what will happen if you check out, you will always get the latest change. But at 4, when you have done this merger, you are putting a tag. So which means that after that, when development is happening on the trunk or on the development branches, say even after you have reached 9, other development has been checked in, even then you can go back and check out 4 to see what was there. You can get that. So basically, tagging basically internally means that you are making yet another copy of the whole thing. I mean, in reality, a total copy is not done. There are various optimization diff management techniques used, so that you just keep the differences in the tag unless the differences are too large, and so on, and you can reconstruct based on that. But it's a costly process in terms of time and space. So you don't tag every day, but the important points you tag, and that is the way you can manage older versions with the newer versions in the same version control system. So this could be your one major release 4. 9 is your other major release. 2, 3, 6, 7 are minor releases that you have made. And at this point, you have marked that minor release. There could be subsequent branching of patches, hotfix, and so on, and again comes back. And 4 and 9 are parallelly tagged. So while you are supporting 9 for some customers, you could still support 4 for other customers, and you can check out the state of 4 at any point of time. You can create a new branch from there and do a subsequent development on the code base of 4, while code base of 9 is actually what is the current one. Right. So that's what all of branching is all about. That's what is written here in terms of this. So naturally, when you branch out, the branch you came from is known as a parent. So this branch has one as a trunk as a parent. This similarly, the branching of branching. Let me show you another picture. So this is a little more realistic. So this was a beta version 0.9. You had number of changes there. And so this was a branch that was done. And then with 0.9, you marched that into 1.0, the major release. You had some bug fix releases here, not major. It's not 1.1. It's 1.0.1. So you are having patch releases here. And then you merge that with the original one in this minor release. So otherwise, you are having 1.0 as a major release and 2 bug fix releases, 1.0.1 and 1.0.2. And then you merge this 2 into 1.1, which is a minor release. You have another bug fix release there, and merged it to 1.2 to get your next major release with 1.0, and so on. Right. So it could go up to several multiple levels depending on the branching that you are doing, or you can completely take out a separate branch and start working on a product derivative, or start working on a different platform release. You have this product on Linux, and now you have significant number of Windows customers. So you take out that whole branch, start a new development of migrating the Linux code onto the Windows code, and you'll have sub branches and all that. So any branch that it emanates from the other branch, the source branch is called the parent branch, and the other branch is called the child branch. And by trunk, I'm going back one slide. By trunk, you mean the branch which does not have a parent, quite obviously. So this is branching, this is merging, and when you decide to discontinue, you stop here, and this typically is called forking. So fork here has a different connotation compared to what it means in operating system or in distributed computing. Fork is kind of merging, but no, in version management, branch management system, merging is merge. Forking is forking is not merge. In distributed system, forking is actually getting out multiple computations, either in processes or in threads. So that's called branching here. Merging is getting them together, which is join. But fork here means that you discontinue that. So you have forked the version 10, this branch. So which means that development on that are stopped. Right. So this is more or less that what I wanted to discuss. I will circulate this slide. It has a number of slides after this, which I don't need to really go through. These are a variety of different tools like memory checker tool, coverage tools, performance tools, and so on. These are for your references. I mean, obviously, you don't have to. I mean, unless you keep working, you will not remember them. But these tools I have just given you a glimpse so that keep this as a reference to you, so you will know exactly where does different tools fall. And after that, I have given sample test plans for the leave management system, for the quadratic equation solver. Actually, I mean, the quiz that you solved is actually solved out here. I mean, the test plan, the entire test plan, all this. This part is what was set on your quiz, last quiz. So that's forming the test plan. And then finally, I have put a test plan for a red-black tree. I'm sure you have done red-black tree as it's a kind of a binary search tree. So this is more to give you a feeling of how does the test plan of a library. So these test plans. So we will not walk through these. These are for your references for future. And let me check if there is any question. So there are several things that we could not do, but more or less, I'm drawing this to a close on the software processes, primarily the testing, development, and maintenance processes, so that you have got a fair idea about the basic set of processes. At least some processes we have discussed in depth, some you have practiced in the assignment, and some you just got to know. But I would strongly suggest that whatever is your interest, just get into some open source development practice. That's a big learning ground. You will never learn more than if you start contributing to some open source project which is of your interest, because that will take you through all these processes for life. So from tomorrow, we will discuss some of the other topics. I will try to do a little bit of design pattern and some bit of processes that your seniors would do in the organization. And I want to discuss a little bit about software engineering and AI, the interplay between artificial intelligence and software engineering. Before I have probably 3 lectures left, so only part of this will happen. 14th is the last class, right? As far as I remember. Next Wednesday is the last class. Is that right? You do not know. Okay.
Yes, sir.
Okay. So so we have 3 classes. So I'll try to do glimpses of these a little bit. Okay, then it is time. Have a nice day, and we'll meet tomorrow in the scheduled hour. Bye.